To find maximum minimum, we need to find first derivative of the equation, and after that we will equate this equation to 0. Here one formula is used, that is x to the power n. ddx of x to the power n will give n into x to the power n minus 1. And you see here in this 3x square, it came from x cubed, so that is x to the power n formula. Now after finding this dy dx for maximum minimum, we have to make dy dx as a 0. dy dx here we have found 3x square, so we have found dy dx 3x square minus 18x plus 24. So this will be equal to 0. Here you can see that 3, you can take it common. So basically we are eliminating 3. And then x square minus 6 is okay. Now to find the solution of this, we will use the middle factor method. So 8 you have to break and you have to make minus 6. So here is the brackets. Then okay, this middle factor method is followed, and that gives two factors, x minus 4 and x minus 2 is equal to 0. Now we know that okay, means either of them, to solve this equation you have to say either of them could be 0. So one is x minus 4 equal to 0 and this x minus 2 equal to 0. So if x minus 4 is 0, we get x equal to 4. For x minus 2, we get x equal to 2. So this is the original plot of the given equation, and you see that in x.2 and x.4 you will find up and down. That is the local maxima and minima, and our differentiation is able to catch or detect it so nicely, this fact. We will do the second derivative, like after taking dy dx 3x square minus 18x plus 24, this we have taken, and then we will do the second derivative of that, like ddx in both sides we will take it. So now 3x square minus 18x plus 24, these 3 we have done the second derivative. Okay, so see, we are doing now with x equal to 2, what will be the value for double derivative? What should be the value for double derivative? So we will put the value x equal to 2 in a double derivative, and we got minus 6. That means it is a negative value. If it is a less than 0, if the double derivative value is less than 0, then that value here x equal to 2 indicates this will give maximum value for the function. So if double derivative is less than 0, that will give maximum value for the function. Y has the maximum value. So now if that's so, what is the maximum value? So what you need to do that you take the equation, that y equation, which was the y equation is x cube minus 9x square plus 24x and then minus, okay, so you are placing this value 2 and then we'll go for calculation, and these will, let's see that what the value it will provide. So we are calculating the value for y max values, that means what is the y or function value for x equal to 2, and after doing that, this is merely calculation only. Whatever value we get, that is a y max values. So that means 8 is a maximum value for the function. Here we are putting y, so that at x equal to 2 we will get function, we will get maximum values and value is 8. Same process we can remember that we got x equal to 2 and x equal to 4. That 2 point we have a maximum. So now we are testing with x equal to 4. X equal to 4, we'll put this value in a double derivative. So double derivative was 6x minus 18. So there we'll put x equal to 4 there. So this gives value 6. So that means at x equal to 4, double derivative is greater than 0. So that means this will give minimum value. X equal to 4, put, will get a minimum value for the function. From the plot, it is very evident that all these maximum minima are the local, not the absolute. To calculate what is the minimum value, what you have to take? You have to take the equation and simply put x equal to 4. That's all. This is merely a calculation part. Okay. So you take the equation and then you put the value x equal to 4 there. So this y mean value has come as a 4. That means at x equal to 4, function will get minimum value and that value is 4. Now let us see the total process from the beginning. First is we have to do the first derivative of the given function, and after that that first derivative will equate to 0, that is that equation equal to 0, then we need to solve the equation. So once we solve the equation, we'll get the value of x. So that value indicates that is the point. That is why x equal to here 4 and 2. These 2 points. Here in these 2 points, there one could be maxima and one could be minimum. So to test that whether that x equal to 2 or gives maximum or minimum, we need to do the double derivative. And once the double derivative done, in the double derivative you have to test it with x equal to 2 here. So if that value becomes positive, that is for minimum, and it becomes negative, that is for the maximum. So this is the total process. And so this double derivative is used for taking decision whether this is a maximum or okay at particular value of x. And if in the question asks what is that maximum and minimum values, then only you can take the original equation which was given. There you put the values and you can get the minimum and maximum values. Hope this has helped you. See you in the next video. Thanks for watching. Please subscribe my YouTube channel.